Okay. So 4C, and are you able to see my screen as well?
Yes, sir.
Okay. All right. So first one, Avya, can you help? 3A, what would you do with calculator? Because 4 decimals. What would you do in this case?
So I'd just do ln 20, right? And then whatever like the answer is, it'll just be e raised to the power that.
Exactly. Right in the form. So basically, yes. So the question is 20, you have to write it as e power x. Right, Lily? So which means, do you agree that x is ln 20?
Yeah.
Okay. Okay. So look up ln 20 on the calculator, whatever that is. Let's say it's, I'm just making up something. I think it'd be close to 2.8 or something.
Just 1 second. My GDC is in the other room. Can I quickly go get it?
Yeah.
So we have to do it to 4 decimal places, right?
Yeah. Whatever. I'm just making up some number, right? This might not even be right, right? I'm just randomly guessing. How much is it? Ln 20 on the calculator?
2.9957.
Sorry. Please repeat.
So 2.9957.
2.9957. Okay. Yeah. So then you'll just say it is, okay, e power 2.9957. As simple as that. So yeah. So you look up on the calculator and just write it like this, Hana. 2 power 0.9. Okay.
Yeah,
Same for
that's
same.
curious of how to solve it. Like I thought there was you didn't know what E was, so that's.
Yeah. And then what else? Which other question or questions?
4A is similarly solved, right? 4A for the same exercise.
Exactly. Log x equal to 3. By default, if they don't put a log, that means put a base, that means the base is 10. So if you say log x is 3, that means log x to the base 10 is 3. In which case you don't even need a calculator. X is just 10 power 3. Agreed?
Yeah. Yeah.
Just 1000. Yeah. What else? Sumaira, Avya, anything from you guys? Or Hana, more from you?
Yeah. 8A. Could you solve 8A?
8A.
Of the same.
Yeah. Did we do one of these, 8A or 8B? I'm not sure.
Maybe 8B in the form of the quadrant.
Okay. Yeah, we could do 8A, or can I?
So didn't we do this last class?
I thought we did. Yes. Okay. So Sumair, you want to help? How did we do this 8A?
So this we took e raised to x as a variable. We stored it as a, I think. So you can store it.
Correct. E raised to x is, let's say u, then this is u square. E power x is u square.
Yeah.
Equal to 3u. Agreed? Ahana? But don't cancel the u. Always get into the habit of writing this way. So u into u minus 3 equal to 0, which means there are two options. Either u is 0. Just think of this as one bucket. So this could be 0, or this bucket could be 0, u equal to 3. So this means, now putting it back, so e power x is 0, which is not possible at all, right? Unless x is tending towards minus infinity. And then this is e power x equal to 3, therefore x is ln 3. Yeah, makes sense?
Yeah.
Yes. Sir.
Yeah. What else?
So 7A, B, and C. I tried solving with my GDC, and I think I got really close to the answer. I mean, my method was right, but I think I did some calculation wrong. So could you show those?
Okay. So first one, there's not much scope for mistaking. Not much scope for making mistake, right?
Log 300 upon log 3.
Yeah, log 300 to the base 3 directly you can do, or you can do log 300 upon log 3, right? If your for example, let's say your calculator supports only log to the base 10. You can use the change of base rule. I mean, all calculators support multiple bases. I'm just saying, for example, there could be a trick question saying you have a calculator which only supports base 10. How do you do this problem? Just change of base rule. It's log 300 by log 3. Yeah, makes sense? Okay. So this one next. Very similar, right? So 5 power 1 minus x. Let's get all the numbers on one side. So 0.15 divided by 30. Whatever that number is, I don't care. How much is this? This is be 0.005 probably. Correct? 0.005, 5 power 1 minus x. Okay, now I can take again log to the base 5 of 0.005. Right, this would be 1 minus x. And this you can put on your calculator, log of 0.005 to the base 5. And
So
then
because I haven't really used my calculator very much, I only know how to do it using base 10, which is
No.
why in the first one also I used.
okay, pull up your calculator right now. You should be able to change the base. When you enter the log itself on your GDC, there'll be a base thing. Can you just check? All of these questions will require log with a base. So you should be able to enter a base. Can you look it up on your instructions on your this thing, GDC?
Do it, so when you go and run matrix, there's this option for math.
Say that Abhi again. I didn't understand.
So like when you go and run matrix, there's this option for math on F4.
Mhm.
So you press that, then there's this option for log AB.
Log A to the base B.
Yeah, no, so log B to the base A, and then so you press that, that's F2.
Okay. I
And
don't
then-
have the instructions manual or whatever, right? So each model might be slightly different.
Yes.
But Ahana, even if you didn't have, you can still do it by the change of base rule. That's the beauty of change of base rule. I can write this as log of 0.005 upon log of 5. So your calculator, you can still enter this, right? That's the advantage of change of base rule. And then whatever number you get, it's 1 minus x equal to that and solve. That's it.
Yeah, I messed up. I didn't move the 30 to the other side. So that's why I was like trying to figure out how to use 30 within the 5.
Okay. All right. Can we do part C, all of us? 3 power x plus 2 equal to 2 power 1 minus x. Can all of us do it? Work it out, please. With the calculator, of course. Again, multiple options are there. You can figure out what is best. Yeah. How's the progress? Have you done almost?
I'm still thinking, so just give me 1 minute.
Still thinking. I mean, working out is okay, but not much to think, right, in this question. Sumer, how about you?
I'm just seeing if my answer fits.
What is your answer approximately?
Since it's wrong.
Ahana, what about you?
So I tried it once, I got it wrong. I'm trying it.
So never mind, so it works. So what I did,
What is your numerical answer approximately? Minus 0.85 approximately.
minus 0.84.
Okay, I just did some hand calculation. Yes, that's right. Okay, cool. Wonderful. Avian, Hannah, more time or should we discuss?
We can discuss, sir. I'm not getting it. I tried.
Okay. In fact, Sumer, why don't you go ahead and describe? What did you do?
So what I did with this was I broke it down. I broke both of them down. Like I wrote 3 raised to x plus 2 as 3 raised to x into 3 raised to 2.
Yeah.
Then I wrote that as 2 raised to 1. And instead of writing, I want to make 3x and I want to make 2 by x. So I wrote 1 by 2x raised to x.
So you mean like this?
No, I wrote 2 into 1 by 2 raised to x.
Okay, fine. Okay, so you wrote it like this. 2 into 1 by 2 power x. You guys agree with what he has done so far? Okay, cool. Continue, please.
Then I took it to that side. So
Okay.
and I took 9 on that side. So I got 2 by 9 is equal to so what this came out to be, so it was 1 by 2x. So yeah, okay, we can write like that. But what I had done was just 3 by 1 by 2x, like 3 raised to x by 1 by 2x, which just gives 6x, same thing.
Yeah, 6 power x.
So it just became 6 power x equal to 2 by 9, and then just log 2 by 9 to the base 6.
Excellent. Okay, this is one of many ways in which you can do this problem. I'll show you another way. Okay, this is perfectly fine and well done. Okay, so log of 2 by 9. Is this method very clear, guys? Avya, Ahana? Okay, so another way. In fact, I want you guys to try all of these and convince yourself they're all giving the same answers. Method 2. Method 2, I will say, take logs to both sides to the base 10 straight away, right? Take log to the base 10, So it's x plus 2 times log 3 equal to 1 minus x times log 2. Agreed? Collect all the x terms together. So x is with log 3 here, x is with log 2 here. So x, if I take outside and bring the log 2 to this side, x into log 3 plus log 2, correct? Equal to, now here on the right hand side, I have log 2. And on the left hand side, I have 2 times log 3 that can go to this side. 2 times log 3. Yeah, so if I guess with me, and therefore x is log 2 minus 2 log 3 upon log 3 plus log 2. Either you can directly feed it in your calculator, or if you want, you can go one step more if it helps. Log a plus log b is log ab, which is log 6. Correct? And the numerator of this is log 2 minus, what is 2 log 3? Is log 9, log of 3 power 2. You guys remember the logic, right? Log of a power m is m times log a. So this becomes log of 2 over 9 upon log 6, which is exactly what Sumer had got. If I use the change of base rule, it becomes log of 2 by 9 to the base 6. In this case, I'm treating both to the base 10. Is this method also clear? Okay. Now, I want you guys, okay, I'll do one more method, right? Or in fact, I'll ask you to do. Instead of taking to the base 10, can you guys take both sides to the base 3? Okay, take both sides to base 3. Take both sides, take log on both sides, log of both sides to base 3. And see whether you get the same answer, please. Are you clear on what I'm asking you to do?
Same answer, sir.
Same answer, right? Okay.
can you sorry, so can you explain this once again?
Yeah, I'll explain, and then I'll ask you to do one more. Okay, so if I take to the base 3, what happens? Okay, I'll literally write it out. Log of 3 power x plus 2 to the base 3 equal to log of 2 power 1 minus x to the base 3. Okay, so this guy, since it's 3 power something and to this base 3, it is simply x plus 2. Agreed? Yeah, and the right hand side is normal, 1 minus x times log 2 to the base 3. Okay, again, like before, I'll collect all the x terms to one side. So x plus x times log 2 to the base 3. I'll move that to the left hand side. On the right hand side, I have log 2 to the base 3, and then minus this 2. The 2 has gone to the right hand side. Yeah. So now x into, what is this? 1 plus log 2 to the base 3 equal to log 2 to the base 3 minus 2. Okay, therefore x is log 2 to the base 3 minus 2, right? Whole upon 1 plus log 2 to the base 3. So if you numerically work it out, it should work out same. But if you have to prove it's the same quantity, I'll convert everything to the log to the base 3. I will write it as log 2 to the base 3. I will write the number 2 as log 9 to the base 3. Right? And similarly, I'll write the number 1 as log 3 to the base 3 and log 2 to the base 3. Right? And this is log of 2 by 9 to the base 3 upon log of 6 to the base 3, which is the same as any of these, right? Except that the base is 3 in this case instead of 10, or in case instead of 6 in the earlier case, right? Just same as log of 2 by 9 to the base 6. Right? You agree that all of these are same?
Yes.
Yeah. So just for practice, can you guys do the same thing? Take everything to the base 2 instead of base 3. Same problem, base 2. And convince yourself you're getting the same answer. Yeah, how's it going, Ahana, Abia? Able to get the same answer? Sumer,
Yes, sir, it's the same thing.
you are right till final step.
Yes, sir, but I'm just 1 second.
So I got it.
Wonderful. Okay. Cool. Abia, Sumer will be able to finish it up. Similar idea, right? should be able to get the same answer. Log 2 by 9 to the base 6 in different forms. It
Yes.
can be different bases, as we saw, base 2, base 2, base 3, base 10, or no base at all. Directly log 2 by 9 to the base 6. Okay, cool. Any other questions, Lily? Keep going. Otherwise, I'm going to go back to exercise 3A, exponents, and then come back all the way.
I just don't know 10, 11, 12, but they're all related to graphing. So
Okay. All right.
Yeah.
Let's come back. Let's go to 3A and exponents, right? Let's finish exponents thoroughly. Page 119, guys.
can I just go over these sums for like just 2 minutes? Then after that, can we go? Because like I'm just a little worried. So
Sorry, I didn't understand. Page 119, review set 3A. What was your worry?
I just review the question I just solved like for like 1 minute. It'll take me like 1 minute.
Sure. Which question? I'm not following. The question that we just did.
No, I want to like go over it myself because like I'm a little
Okay,
I'm a
sure.
little-
Sure. Take a deep breath. No worries. Look at Sumer. He's bindas. Look at Avia.
1.
Okay. All right. Exercise 3A, page 119. Can we do 3B? I'll put it up here as well, but you also should have it in your text. F of x equal to 3 power x. You don't have to do 3A, just do 3B.
Yes, so I'm done.
Yeah. What is it?
So 9.
9. Fairly straightforward, right? Ahana, you're okay as well? 3 power x plus 2 equal to k times 3 power x. Therefore, 3 power x gets cancelled, so k equal to 3 power 2, which is 9. Okay. Can we do 5B? 5B. As a power of 3.
Five minus 9x upon 2
5 minus 9x upon 2.
to the
Okay.
power of that. Yeah.
5 minus 9x upon 2. We are supposed to, 3, you mean 3 power like this. 5 minus like this.
Upon 2. No, the whole upon 2.
5 minus 9x whole upon 2. Okay. Is this what you guys get as well? Sumer and Ahan. Avia, sorry. She's got this.
So just give me 30 seconds.
Okay.
So it matches the answer behind.
Matches the answer behind. Yeah, wonderful. So I'll just do it in case. So it's 3 power half whole power 1 minus x into 3 power 2 whole power 1 minus 2x. So we just have to multiply, right? So it's 3 power half minus half x and then plus 2 minus 4x. So it's 3 power 5 by 2. I guess 2 plus half is 5 by 2. And then 4 plus half is 9 by 2. Which is indeed what she has. 5 minus 9x whole upon 2. Yeah, straightforward. Okay. Let me see if I can make up a question. These questions are fairly easy. Okay, I'll give a more difficult one, right? Can we write, let's see, 2/5 root of 1 by 27 should be written as let's see, square root of 9, no, not square root of 9, square root of cube root of 9 power x. Find x. If you have no clue, you have not done anything even close to this, I can do one problem and then help you with another one. What do you want to try it? Okay, cool, nice. Go ahead, please.
So we're not allowed calculators, right?
No calculator needed for this.
So is x an integer or like?
No, x need not be an integer. X could be anything.
So I got minus 11.2.
Louder, please. Minus
11.25.
11/1/4.
No, yes.
Okay,
I got minus 45 by 4. I haven't.
which is
simplified
same
it.
as, right?
That's
Which
the
is same. Minus 45 before is same.
I haven't simplified it yet. I'm not sure. Yeah.
Yeah, I mean, 45 by 4 is 44 is 11 times, right? As you say it, you can simplify it, right?
Yeah, I just
Okay, Sumer, you also concur.
I don't get this thing, so.
Okay, so let's discuss. So first of all, when I have some number here, like 2/5, right? That means it's 1 by 27 power, the reciprocal of whatever is sitting here, right? Plus power 5 by 2. Agreed? So we have this should match this. Correct? And then obviously both 27 and 9 are powers of 3. So it's 3 power minus 3 here. 1 upon 3 power 3. Power 5 by 2. So this is 3 power 2 whole power 1 by 3, right? And then whole power x. So effectively, this is 3 power minus 15 by 2. And here I have 3 power 2x by 3. Therefore, minus 15 by 2 equal to 2x by 3. Therefore, x is cross multiply minus 45 by 4. Yeah, well done. Cool. One more. So 0.125 cube root of, oh, sorry, 1 second, I'll just write it out and then again, no calculator. No? Okay, find A, B, and C. The numerator is 0.125, 0.125.
Oh, so I got my answer.
Okay, go ahead, please.
So A I got minus 3/8. B I
Go-
got minus 2/9.
Just one second. Huh? So A, B, and C. Okay, your answers minus 1/8. You said
No, so minus 3/8.
minus 3/8. Okay,
Then B minus 2/9.
Okay.
And C minus 2/3.
I got the exact same answer.
exact same answer. Very good. Okay, so very likely both of you are right then. Sumer, you're almost there.
No, I got this only.
Wonderful.
I'm just a bit confused on the B part.
And finding the B.
Yeah.
Okay, so B is related to power of 5, right? So this is 5 power minus 3 whole power B. So it's 5 power minus 3B. And this guy is
Yes.
actually not.
What I thought. This is what I thought. Yeah.
Okay.
I just-
Okay, cool.
So will the 0.125 change in the terms of 2 and the 25 below will change in the terms of 5?
Exactly. 0.125 looks deceptively like related to 5, but not. It's actually 1/8. So it's related to 2. So it's 2 power 3 or 2 power minus 3, 1/8, right? Yes, you're absolutely right. Okay. So these questions in the textbook should be much easier than what you've tried now. Expand and simplify, find the value, blah, 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 2 power e power 2x. Maybe can we just do 9c? Mental problem by now. E power 2x equal to 1 by root e. Can someone without using pen paper call out the answer? 9c.
Minus 1/4.
Excellent. Yeah, so the right hand side is 1 upon e power half, which is e power minus half. So minus half equal to 2x, x equal to minus 1/4. Wonderful. Okay. Graphing. Are you guys comfortable with graphing? Right? Can we do question 10? So okay, basic funda I'll tell you, right? Any exponent, just 1 second, control 6, I'll just draw pair of coordinates. Okay, so okay, so if I look at 2 power x, right? 2 power 0 is 1. 2 power 0 is 1. 2 power 1 is 2. So this is 0, this is 1, this is 2. 2 power 1 is 2. 2 power 2 is 4, right? So which is why we say exponentially it's raising, right? So it's 2 power, on the negative side, 2 power minus 1 is half. 2 power minus 2 is minus 1/4. So it'll gradually decay. So this is 2 power x, right? Any power of anything to the power of x, as long as the number is more than 2. For example, 3 power x will be even steeper here, right? So it'll be even steeper here. So 3 power x, I mean, I'm not drawing to scale, but something like this, right? And it'll be even flatter, or rather even going towards 0 much faster, right? So 3 power x will be steeper. And then e power x will lie somewhere in between these two, because e is 2.71, right? On the other hand, if I bring it down from 2 power x to, let's say it's 1.5 power x, 1.5 power x will be something like this, right? 1.5 power x. And if I bring it down to 1 power x, that's the flat line. 1 power x is just 1 power x is just this flat line. So this is 1 power x. And then if I go below 1, if I do half power x, that'll be the mirror image of 2 power x, right? So half power x will be the mirror image of 2 power x. Why is it the mirror image? Can someone tell me why is it the mirror image? Okay, not able to draw it well, but it's the mirror image of the red one. So this is half power x. Any idea why it's the mirror image of 2 power x?
Because
It's the reciprocal, right?
It's the reciprocal. So why does it have to be the mirror image? I heard one other voice. Sumer, was it you? Or was it Arya?
Yeah.
Yeah, go ahead, Sumer.
the reciprocal, right?
It's a reciprocal, but why does it have to be the mirror image? Same question. Why does the red and orange have to be mirror images? So maybe that's what you meant. So this is 2 power minus x. So if I have f of x, and if I have f of minus x is nothing but take f of x and reflect over the y-axis. Have you done this concept? If you have f of x, then we'll do it again in more detail, transformation of functions. But this is a basic transformation, right? If I have f of x, and if I'm asked f of minus x, it's literally flipping around the y-axis. So 2 power x has flipped around the y-axis to become 2 power minus x, which is nothing but half power x. Does it make sense? Yeah, Sumer? Okay, cool. So with that background, can we do question 10? Map the following. Small a, small b, small c, small d, small e to the capital ones. Which is which?
So can you repeat what you just said?
Question 10. Question 10. Map the following from capitals to small. This question. Question 10. Okay. How shall we do this? Maybe each person can. Okay. Ahana, why don't we start with you? You can pick any one letter, small letter. You can tell me which one maps to that. Choice is yours.
C is E. The capital letter C is the small letter E.
Okay, or rather, I'll put it here like, so you're saying this is capital C. Yeah,
Capital C, yeah, equal to E.
whatever I've written, right? That's what you mean, correct? Small e is capital C. Let's go with the small. Okay, Avya, do you agree with this one, right? Minus e power minus x. It's a inverted one. Okay, why don't you pick another one, Avya?
So small. So small c is equal to is a.
Small c is a, exactly, right? It's the same e power x lifted up by 1. So at origin, instead of, at x equal to 0, it's the y-intercept is 2. And then the asymptote is essentially what it's heading towards as x goes to minus infinity. It's lifted up from 0 to 1. Yes. Okay, Sumer.
So the small b, I think, is E, like capital E.
Small b is capital E. Yeah. Yeah. So 3 times 2 power x. So the y-intercept is 3. And then otherwise the shape itself looks like 2 power x, but a steeper version of it, a scaled version of it. Okay. Avya, back to you. Sorry, Lily, Hannah, back to you.
Small d is B. Small d is capital B.
Small d is capital B. 3 power minus x. Yeah. So that looks like 1 by 3 power x or 3 power x flipped over. Same thing that we just discussed. And then this should naturally be the last one that's left, which is what? A, B, C. This should be capital D, hopefully. Minus e power x. Yeah. Okay, sounds good. So can we do 11? All 3 parts, fatafat? Almost like a show and tell question. Very. Sumer, why don't you start with the first one, 11a?
So just y square, right?
Y square. Okay. Ahana, a power minus x is
1 upon y.
1 upon y. Okay. And then Avya.
Hello.
Yes, Avya.
So say minus root of y.
Minus root of y.
So let me just check. Yeah, sorry.
No. Avya, you're overcomplicating it.
So 1 by root of y.
Yeah, exactly. 1 by root of y.
So it's yeah.
Yeah. So if at all anything, you probably meant y power minus half. So
Yes.
this is 1 upon y power half, which is y power minus half.
Sorry, this got a little confusing now.
Okay, no problem. So 3b, let's see. Exercise 3b. Okay, can we do question 5 on the same set of graph paper? It's a graphing question, so you all can work it out, and then the y-intercept and the equation of the horizontal asymptote of each function. You can just tell me what each of these are. All of you understand asymptote, right? Anyone? Ahana, you're okay with asymptote?
No, I'm not sure about it.
So asymptote is as one of the variables approaches infinity, what does the other one approach? Okay, so okay, all right. There are 2 types of asymptotes. One is horizontal asymptote and one is vertical asymptote. Forget this question for a second. So suppose I have a simple e power x, right? In fact, I'll say it's I won't say e power x. I'll say e power x plus 3, right? So the entire e power x is lifted up by 3, right? So the graph will look, let's say the scale is like 1:2. So the graph will look something like this, right? So far out to the left, when x approaches minus infinity, this will approach e power minus infinity plus 3, which is approximately 3. Do you agree? Right? If x is minus zillion, then e power x is practically 0. So effectively, it's approach 3. So this is the horizontal asymptote. It's almost going huggingly close to this horizontal line, but not touching that horizontal line. So the horizontal asymptote in this case is the line y equal to 3. Y equal to 3 becomes the horizontal asymptote. Right? And similarly, you can have a concept of a vertical asymptote. So for example, again, a completely different problem. Suppose I have, we will do more on this when we plot functions. So suppose I have, I plot 1 upon x minus 3, right? So at x equal to 1, it's well behaved. X equal to 2, it's well behaved. X equal to 4, it's well behaved. At x equal to 3, I'm getting 1 upon 0, which is not well defined, correct? However, as x can be as close to 3 as possible. Only the forbidden line is x equal to 3. So I'll put a dotted line at the forbidden line. X cannot be 3, but x can be very, very close to 3, right? And as x approaches 3, what happens on either side? Let's say x is 3.000001. Then the denominator is a very small positive quantity, which means this fraction is going to go up till positive infinity. So it's going to go almost till positive infinity. Agreed. And then similarly, on the as x is 2.99999, the denominator is almost 0, but negative 0.00001. So it will go to 1 by infinity, 1 by 0. Sorry, it will go to a large negative quantity. In other words, the graph of this will look something like this. It will have behavior. What happens later, that's a different story. But very close to this vertical line, the behavior will be like this. So it's a vertical asymptote where you don't reach this vertical asymptote at all. The equation of this vertical asymptote is x equal to 3. So that's the concept of horizontal and vertical asymptote. Right now, back to this question. So for both of these, 2 power x and 2 power x minus 4, what is the y-intercept? What is the horizontal asymptote?
So for 2 power x, it's 0, y is equal to 0.
2 power x, which is 0?
So the horizontal asymptote.
Horizontal asymptote is y equal to 0, because 2 power x will be the similar thing that we have studied so far. It's 2 power x will look like this. So the equation of the horizontal asymptote is, as you rightly said, y equal to 0 is the horizontal asymptote. And what will the y-intercept be? Avya?
Oh, so you asked me. So 1 only.
What did you say, Avya?
So I said 1.
1, correct. Yeah, it passes through 0,1. So the intercept is 1. So it passes through 0,1. Okay. Sumer, what about for 2 power x minus 4?
So basically, an asymptote is an unreachable line, right, for that graph?
Correct. You're almost right. Hold on to the thought. However, that's not entirely true. For example, you can always have functions in maths, something like this. Sorry. Okay, so I'll just draw it and I'll show you, because I want you to get rid of that notion. A lot of people ask the same question, right? So the horizontal asymptote for some other function can be a line like this, right? The function can behave. I can always make up a function which will behave something like this. It cuts through the horizontal asymptote multiple times. It's not like it's not an unreachable quantity. It's a quantity which you approach towards as x tends to infinity or x tends to minus infinity. So far out, how is the behavior going to be? Very loosely. It doesn't mean it cannot touch this value. In fact, the example I showed you, touch through that same value multiple times. And then far out, it's going to, even then it's called asymptote. Right? But generally, you don't see this behavior. The behavior that we described earlier is more common, where it's fair to say that you never reach that, you're approaching that. Okay, so Sumer, 2 power x minus 4.
So is this just minus 4?
What is minus 4?
The horizontal asymptote.
you have to be technically clear. Y equal to -4 is the horizontal line. Just saying -4 doesn't mean much. So the horizontal line becomes y equal to -4. So the graph will look right. So axis like this. So 2 power x minus 4, right? 2 power x minus 4. So it will go below like this. And then what will this thing be? X intercept, sorry, y intercept.
Zero.
No,
-3.
-3. Because when x is 0, then what is the y value? That's the y intercept, right, Ahana? So when x is 0, it's 1 minus 4, which is -3. So this point is 0, comma -3.
I accidentally found X intercept.
And what will the x intercept be? Lily, Ahana, sorry. You have to change your name. I keep calling you Lily and Ahana. I want to be consistent. In my mind, it's Ahana, but I'm seeing as Lily. It's confusing. Okay, what is the x intercept, Ahana?
Intercept is
Your
2.
mute.
X
2.
is 2.
X is 2.
Yeah.
Yeah, x is 2, right? So 2, comma 0. So the x intercept is 2, y intercept is -3. Okay. How about suppose I have a third function? Let me just it's too much clutter here, right? I'll just paste this. Okay. Suppose I have another function which is 2 power x minus 4. How will this function look like? As in, comment on it. It might have some horizontal asymptote, some vertical asymptote, some x intercept, whatever, right?
So y equal to 2 into 2 to the power, right?
Sorry,
Y equal to this, right?
y equal to this, yes. Yeah, 2 power x minus 4 is your y. How will this function look like?
So the y-intercept would be 1/16.
Y-intercept will be 1/16. Yes, because when x equal to 0, y is 2 power 0 minus 4, which is 1/16. Yeah, y-intercept is 1/16. So it passes through 0, 1/16. So this is the y-intercept. So y-intercept is just the y coordinate of the point it passes through on the y-axis. So it's 1/16. Yes. But how will if we want to describe the graph, how is it? How will it look like? What is there a horizontal asymptote or vertical asymptote for this?
Horizontal, right?
What is the horizontal asymptote?
Zero only. Y is equal to 0.
Exactly, because it's the same behavior as 2 power x. When x is -1 million, x minus 4 is -1,000,004. Doesn't matter, right? So it approaches the same horizontal asymptote of y equal to 0. Right? So how will you compare these two graphs? Suppose, is there a way to relate these two graphs? So earlier we said these two graphs are related in a way. We didn't say, but it's the first graph shifted down by 4. It's the entire 2 power x minus 4, which means you're shifting it down. Again, we'll do it all in detail when we do transformations of functions, but this is fairly logical, right? The 2 power x was the original one. And in the question 5, it was 2 power x minus 4, which is bringing down the entire function by 4 units. That was clear. What about the new function I said? 2 power x minus 4.
You shifted to the right.
Excellent. Yeah, it's shifting to the right by 4. Okay, we'll come to that in detail. If you have not done that, it's fine. But if you know that, that's great, right? So it's shifting to the right. So unfortunately, it's not obvious, right? When I have minus, your okay. So if 2 power x looks like this, so 2 power x looks like this, let's say, then 2 power x minus 4 will look like the orange graph, right? Orange or red, whatever, right? It will be shifted right by 4, right? You'll see this later. Why? I mean, you can see it now also. So let's say x is 5 here, right? So effectively, it's the same behavior as 1 because 5 minus 4 is 1, right? If I put x equal to 5, is as if putting x equal to 1 in the 2 power x, right? Which is why I shifted right. But main point is, if I have f of x, and then the way I go to f of x minus 4 is by shifting right by 4. And that's what is happening in this case. So 2 power x, x is getting replaced by x minus 4. So it's shifting right by 4. Again, we'll do it in detail when we do transformations of functions. Okay, don't worry too much if you did not get it fully. Okay. Okay, question 6. I'm just wondering, should we do it or can you just maybe I'll assign us homework 1 sec. Maybe I'll assign us homework. Ignore question 6. Can you do question 9? Question 9. 3 minus 2 power minus x.
So what part should we do?
In fact, do all parts. Effectively, we have to end up sketching it. So all of them are connected. So if you go in the order A, B, C, D, let's do it in the same order. So first is just making a table for different values of x. What is your y value? Okay, since this not very easy for you to call out, right? It's all graphs. So I'll also do it here. You can just quietly do it, and as needed, you can watch. Okay, shall we pause here with A and B? Do you guys agree with me?
Yes.
And the behavior for B, right? X tends to infinity, Y will approach 3. Ahana, you with me as well on that? Okay. So C and D are more or less related, right? Yeah, for sketching, you have to find an asymptote anyway, or equation of asymptote. So for part D, it's easier, right? So part D is just the equation of the asymptote is the horizontal asymptote is Y equal to 3. And that happens when X approaches positive infinity. So the graph is going to be something like a decreasing graph like this, right? Or rather, it'll be this way. In fact, if you sketch the graph, you'll see it for yourself.
So the asymptote on the graph, and we'll show it with the dotted line, right?
Correct. Yes. And it's y equal to 3. Just don't say 3, guys. Horizontal lines is always y equal to something. Vertical lines is x equal to something. And then here it will go to infinity like this. And draw the horizontal asymptote fully, even though the behavior is as x tends to infinity, right? As x tends to infinity, y equal to 3. Yeah, all of us on the same page? Agreed? Anna, all good, right? Okay, cool. So that was question 9. Question 10 should be easy. Let's go to 3C. Exercise 3C. All of them are fairly simple only, right? Nothing much. Okay, can we do question 9 in 3C? Point 1 comma root 8, that one.
K equal to 1.
K equal to 1. If K equal to 1,
Wait, no, wait,
Then-
wait. K equal to 3 by 2.
3 by 2.
Equal to 1.5.
Yeah, same.
1.5. Yeah, fairly easy, right? Okay. Can we do 10b? 4 power x plus 1 equal to 1 by 8 power x.
Minus 0.4.
Minus 0.4 minus 2 by 5.
Yes.
Okay, same answer, anyone? Same? Okay. Sumer, you're also okay, right? Same, okay, we don't need to do, right? Good, all three got the same answer, I can skip. Yeah, question 11, please. Same sketching, let's get more practice with sketching. All parts. Yeah. Are you guys more or less in sync with what I've drawn?
Yes.
The key things to mark would be the horizontal asymptote, y-intercept, any x-intercept if there is one. All of these are important points in any graph. I'm just saying x-intercepts, y-intercepts, any other key points you want to show. And then later when we do calculus, we'll see all this maxima, minima, the peaks and troughs. Okay, cool. That was 11. Okay, now come back to question, sorry, chapter 4, logarithms. 147 would be 4a. 147 4a, the non-calculator based questions. Can we do 2b? Page 147, guys. No calculator.
So minus 1/3.
Minus 1/3. Very good. Agreed? Question 4d, D as in Delhi. ln of
1 minus x.
1 minus x. Yeah. Okay, I'll just make up something. What is ln of eth root of 1 over e?
Minus 1 by e.
Minus 1 by e. Same answer, others?
Yes, sir.
That's right. Right? So just to expand, it's e power minus 1 whole power 1 by e. So it's ln of e power minus 1 by e whole to the base e. Okay. And I can make it even more interesting by putting something like this. So the original question can be updated to be oh, sorry. Okay, fine. I'll just say okay, can we do this one? ln of this guy
Minus 1.
minus 1, because we already saw that the one within the brackets was minus 1 by e. I mean, or rather without this. So now it just becomes ln of 1 by e, just minus 1. Very nice. So my same, right? Ahan, Avya, sorry.
Yes,
Okay, what happened to Ahan? I thought he was going to join late. He completely missed out. Okay, fine. Anyway, the video is there, thankfully. Can we do question 7? Show that.
So can I try?
Yeah. Oh, you're done? Good. Tell me, please.
So log x to the base 7 can be written as log x base 3 upon log 7 base 3.
Okay.
So and then log 7 base 3 it just gets cancelled out.
Yeah.
And the rest of that, then you just get the answer.
And that's it. Exactly. Just by change of base rule, you get the right-hand side. One step. Yeah. Wonderful. Same, right? Sumaira, Hana, you're with me on this?
Yeah.
Okay. Okay. Question 10. Complete the table, the domain and range. We discussed domain and range, right? Domain is all possible X values. Range is all possible Y values. Okay, let's take turns here. Sumer, domain of log X to the base 2.
So this is just all numbers X can be, right?
X can be any number.
Yeah, X can be anything.
X can be minus 1.3.
Yeah.
No, log X is defined only for positive X, right?
So greater than 1. It's greater than 0, right?
Strictly greater than 0. X is greater than 0. Okay. Avya, what is the range for this? Same thing. Log X to the base 2, what will the range for that be?
So I think greater than 1.
Greater than 1. So what is log root 2 to the base 2?
Close to half.
So you want to correct your answer then?
So I think any number, right?
Any real number.
Yes, any number.
Yeah, because if we look at log X, maybe we didn't do how the function log X itself looks like. So log X looks like this. We did e power X, we did 2 power X, all that, but we did not do log X, right? So log X looks like this. At X equal to 1, if X equal to 1, let's say it's a scale of 1:2, value 0. Log of 1 is 0. Log of 2 will be 1, right? And then log of 4 will be 2, and so on. So it'll go very flat, and here will be very steep. Log of 1 by 32 will be minus 5. So the vertical asymptote will be the y-axis itself. So x equal to 0, namely the y-axis, is the vertical asymptote for log x. To any base, it'll look very similar, right? It'll all pass through 1, 0. Thoda upar niche hoga, depending on whether it's, depending on what base, it'll be like this, or it'll be like this, right? Steeper or flatter. So, but the y value will range from minus infinity to plus infinity. It'll go very, very slowly. It'll go very, very slowly, but it'll go all the way till infinity. Okay. Hana, for ln of x plus 5, what is the domain?
X is greater than minus 5.
Exactly. The portion inside must be greater than 0. Therefore, x has to be greater than minus 5. And therefore, y, and not therefore, and y will still be greater than 0. Right? Sorry, what am I talking? Y is still all real numbers.
Y will belong to R.
All real numbers. Y belongs to all real, for the same reason, right? Y belongs to all real numbers. Okay. What about, I'll make another function. Just 1 second. Log of 3 minus x to the base x minus half. Can you tell me what the domain for this question be? Domain.
So x is greater than 3.
X is greater than 3. Put a value for yourself. If x equal to 4, then I have log of minus 1. Is it even defined? Log of minus 4. The log of minus 1.
Sorry. So x is wait, less than minus 2. Sorry.
X is less than minus.
Yes, sir.
X is less than?
Minus. So sorry, x is less
It's less
than
than 3.
my bad. So x is less than.
Okay.
But x can't be 1. I mean, x can't be 3 by 2 and it can't be 1 by 2 either.
Okay. So all of you are saying partially right things. Collectively come up with one answer, each person. Okay. Anyone? It's just putting together all the rules. When you have log a to the base b, what all did we study? It's just putting together all of that. When you have log a to the base b, what all we saw? We saw that a must be greater than 0. We saw b must be greater than 0.
So
We also saw that b cannot be equal to 1.
So is there x is greater than half or less than 3?
Almost right. And one other thing that Sumair mentioned is also important, that x cannot be 3 by 2, because that will violate this. Yeah. So just to be clear, so just to go step by step, right? So that for people who are watching the recording, they'll understand this as well. So log a to the base b, these are the 3 constraints should be vary about. So in this case, I require 3 minus x should be greater than 0, which means x better be less than 3. B should be greater than 0, which means x minus half should be greater than 0, which means x better be greater than half. And then the base should not be 1, which means x minus half cannot be equal to 1, which means x cannot be 3 by 2. So it can be all numbers between half to 3, but x cannot be 3 by 2. Either you can write it like this, or in set notation, you can write something like this. You guys understand the open interval and closed interval, right? This bracket means half is not included, right? So 3 by 2 is not included. Union 3 by 2 to 3. So you have a break at 3 by 2, and then it will go on till 3. And neither half nor 3 is included. Yeah, all of you good on this? Cool. Can we do question 11? In fact, some of them are easy parts. Let's quickly do all of them. Log 36 to the base 5. Who wants to go? Ahana.
So if it a to the power 5 plus a square.
Way off. What are you doing? After doing so much order problems, you're faltering in this.
Uh,
So I'm giving 2a plus 2b.
Exactly. 2a plus 2b. Kya kar rahe ho, Ahana? Fairly simple, right? So it's 6 square. So 36 is 6 square. So log of 6 square to the base 5. So it's 2 times log 6, right? Which is 2 times log 3 plus log 2. I mean, to the base 5, everywhere. Right? So 2 times a plus b. Agreed, Ahana? Cool. Sumer, you want to take this log 54 to the base 5?
Yes, I think it's just 3b plus 2a. Wait, 1 second.
Okay. So this is 3 square times 2, right? So log to the base 5. So yes, 3 cube, I'm sorry, 3 cube. 3 cube is 27, right? Yeah, so it's 3 times log 3. So it will become 3b. And then I think 1a, correct? Log 2 to the base 5. So a plus 3b.
Yes, right.
Okay. Ahana, you want to try this? 8 root 3.
It'll be 2 cube into 3 to the power half.
Yeah.
So basically it'll be 3a plus half b.
Okay, Avya.
So let me try this.
Convert the decimal to fractions. The easiest thing to do. What is it in fractions, Avya? 20.25.
So in terms of powers of 3 and 2,
No, in terms of fractions, forget powers and all. 20.25 in fractions.
20.25 upon 1.
Fraction. Like it's like asking what is 1.5? You're saying 1.5 upon 1.
81 by 4.
81 by 4, right? Does that ring a bell, Avya?
Yes, so then it'll just be 4b minus 2.
4b minus 2a. Okay, nice. Last one. Who wants to go? Avya? Avya, you just answered. Sorry. Sumer. Again, convert 0.8 bar to fractions.
So just a. So 1 second. So I think it's 3a minus. Yeah, 3a minus 2b.
Excellent. So it's 8 by 9. So it's 2 power 3 by 3 power 2. Therefore, it's 3a minus 2b. Nice. Okay. I think we are just about out of time and we are also done, right? Pretty much. Maybe 12. Can we do one of them? Let's do 12b. 2 ln x minus 3 times. This is non-calculator. Yeah, anyone? Open it up to anyone.
So can I try?
Yeah, go ahead, please, Ahana.
Okay, so we'll basically n x square minus 3ln minus x to the power minus 3x.
Sorry,
Right.
say that again. Say that again.
So
I
we'll
didn't hear you.
simplify it so that we can take the 2 and the 3 inside. So ln x square
Okay.
minus 3, minus ln to the power x to the power minus 3.
Okay. I'll put this way, like this.
Yeah, and then you take it up, so minus 3.
Mhm.
And then when you can use a formula of you dividing it. So ln x square upon ln x square upon x to the power minus 3. Yeah. And then you can take it up. So once you multiply it, it'll become x to the power 5. So ln x 5 to the power equal to 10.
Yeah, continue.
And then because we have ln x 5, this is where I'm stuck.
So x power 5 is e power 10. Therefore, x is e power 10 whole power 1 by 5, which is e square. but you don't need to do so much. What you did is right, but you don't need to stress so much. So straight away, this is 2 ln x, and then minus 3 ln 1, ln 1 over x is minus ln x. We all agree. Ln of 1 over x is nothing but minus ln of x. Ln of x power. Therefore, this is just plus 3 ln x equal to 10. Therefore, 5 ln x is 10. Therefore, ln x is 10 upon 5, which is 2. And therefore, x is e square from there directly. Yeah. But what you did is also right, except that it's slightly complicated, right? Okay, all right, let's wrap here. So I think you guys have a good handle on both exponents and logarithms. I think we have pretty much mostly done. 1 or 2 small topics are there as far as what the goal was for the first 6 classes. But I want to start quadratics next class. It's a very important topic. Sooner or later, we'll need it. So definitely attend. And then next week will be the last before we break, right, for June. Okay, we'll coordinate later. But yeah, keep working. Okay,
Yes.
thank you. Bye. Good night.
Bye, sir.
Bye, sir.